As a biologist, you may need to use the equation C1V1 equal C2V2 while working in the lab. Let's look at an example of how this equation may be useful when culturing cells. In this example, you need to add the antibiotic puromycin to suspension cells cultured in a flask. The cells have been transduced and should now contain a puromycin resistance gene. The stock solution of puromycin has a concentration of 10 milligrams per milliliter. The recommended working concentration of puromycin for this cell line is 6 micrograms per milliliter. Question: what volume of puromycin from the stock solution should be added to the flask of cells if the total cell suspension is 10 milliliters? We can use the equation C1V1 equal C2V2 to answer this question. Pause the video and take a moment to answer the question. Then continue watching to check your answer. To recap, the concentration of the stock solution of puromycin is 10 milligrams per milliliter. The recommended working concentration of puromycin for the cell line being cultured is 6 micrograms per milliliter. The total cell suspension equals 10 milliliters. We want to calculate the volume of puromycin needed in the flask of cells. Let's define the variables in the C1V1 equals C2V2 equation. C1 is the concentration of the puromycin stock solution, and this is equal to 10 milligrams per milliliter. V1 is the volume of the puromycin stock solution that must be added to the flask of cells. This is the value that we will calculate. C2 is the working concentration of puromycin for this cell line, which is the concentration of puromycin that we want in the flask of cells, and this is equal to 6 micrograms per milliliter. V2 is the total volume in the cell culture flask, and this is equal to 10 milliliters. Let's substitute the variables into the C1V1 equals C2V2 equation. C1 equals 10 milligrams per milliliter. V1 is the value that we will calculate. C2 equals 6 micrograms per milliliter. And V2 equals 10 milliliters. We can make the units of concentration the same on both sides of the equation. 10 milligrams per milliliter, which is our C1 variable, is equal to 10,000 micrograms per milliliter. Now we can solve for V1. Mathematically, we make V1 the subject of the equation, and we do so by dividing both sides of the equation by 10,000 micrograms per milliliter. The units of concentration cancel out, so V1 is equal to 0.006 milliliters, which is equal to 6 microliters. So, to answer the question, 6 microliters of the puromycin stock solution should be added to the flask of cells. Here's another question. What volume of puromycin from the stock solution should be added to the flask of cells if the total cell suspension is 28 milliliters? We can use our C1V1 equals C2V2 equation as we did before to answer this question. However, let's take a look at what we know so far. We know that 6 microliters of puromycin is needed for every 10 milliliters of cell suspension. We can use the concept of equivalent fractions to answer this question. 10 times 2.8 is equal to 28. So, keeping the proportions the same, we multiply 6 by 2.8, which is equal to 16.8. Therefore, 16.8 microliters of puromycin stock solution should be added to a flask containing 28 milliliters of cell suspension. Thank you for watching. Please like, comment, and subscribe.